Good morning, everyone. This is Trina here to share about wastewater treatment. And if you have any doubt about this topic, you can communicate either my mobile number or my email ID. This is given in my personal information. And this is very important, the course page. So here I have uploaded all my study material about wastewater treatment and the probable questions, solved answers, all these things are uploaded here. So first of all, you have to join with this code, then you can avail all this material anytime, anywhere. The subject name is Environmental Science. The code is MC301 for odd semester, MC401 for even semester. The streams are CSE, IT, Civil Mechanical, and BAB. The course objectives and outcomes. The students will be able to understand the natural environment and its relationships with human activities. They will be able to apply the fundamental knowledge of science and engineering to assess environmental and health risk. They will be able to understand environmental laws and regulations to develop guidelines and procedures for health and safety issues. They will be able to solve scientific problem solving related to air, water, noise, and land pollution. So our future citizen will take the responsibility to save our Mother Earth. They will acquire skills for scientific problem solving related to air, water, noise, and land pollution. The entire syllabus is given here. First is general part, then the air pollution, and then the water pollution. And today I am going to tell about the wastewater treatment. This part, the layout of wastewater treatment plant. And this is under water pollution. Then another chapters also are there, like land pollution, noise pollution. And then the reference books, you will get here the reference books. These are available in the library. So you can also go through these textbooks. This is the lecture plan, lesson plan. That means which topics will cover in which day. So all lectures, the plan of all lectures are given here. So about the wastewater treatment, there are three types. The most modern of wastewater treatment plants, they use the primary treatment, that is the mechanical, secondary treatment, that is the biological. Biological means the organic waste materials are decomposed by microorganism. That is the biological process. And next is the tertiary treatment. And there are lots of other treatment like ultraviolet methods, that the ultraviolet radiation is given. So main part is, there are three parts: primary treatment, secondary treatment, and tertiary treatment. So the primary treatment, what does it do? It removes material that will either float or readily settle out by gravity. It includes the physical process of screening, comminution, grit removal, and sedimentation. So by this primary process, what we can remove? Mainly the large particle we can remove. So wastewater generally contain organic materials, grease and oil, inorganic materials, nutrients, metals, chemicals, microorganisms. So sometimes we do the pre-treatment, which include the screening of grit removal, is carried out at the start of the treatment process. Pre-treatment is designed to remove solid objects along with grease and oil, which impede efficient wastewater treatment. So mainly the very large particle. So these things we remove first for the benefit of the different types of machineries that we use in the primary treatment. So first part is screening. So screening is the first line of treatment at the entrance to wastewater treatment plant, where 6 new fine screens arranged in parallel channel intercept solid material in the influent wastewater. So here what we do, the main, that means the large particles will be removed by the screening process. So there are the screens, there are specific diameter. If the particle size is greater than this diameter, it will be screened out and our pure water will flow by these screens. So that is the screening process. Next is coagulation and flocculation. So coagulation, flocculation, basically what happens, the materials which are very large particle, they are precipitated down by gravitational force. But there are few substances which are very small. What happens? They remain suspended in the water. In the air also you have learned, that means there are very small particles, that is called the aerosol. They remain suspended in the atmosphere. They are not enough large to precipitate down. Similar way, in the water bodies also, there are very small particles which remain suspended in the water bodies. They will not precipitate down. And there is another problem, the particles are of similar charges, like say all are negatively charges. Then what will happen? They will move from one another by the repulsion method. So they will not combine each other. That is why they cannot form the large particles so that they can precipitate down. So in this case, what we have to do, we have to add some coagulant. So here we have given very common example of the coagulant, that is, one is alum. So we mostly use this alum, that is Al2SO4 3 18H2O. And also we can use other electrolyte like say ferric chloride and ferrous sulfate, etc. So their efficiency will be higher as the charges will be higher. So here for aluminium, we get the charges like say +3, aluminium +3, that is the positively charged. For ferric chloride, that is iron, it is also +3, but for ferrous, that is +2. So this positive, now how it works, how the coagulation flocculation takes place. Then what happens? Then aluminium, this is the positively charged, they will combine with the negatively charged particles and they will coagulate. And after that, when the size will be enough, then it will precipitate down. So this is the part of coagulation and flocculation. So here also you can see it also remove the bacteria also. So screened wastewater might contain suspended particles including bacteria which are too small to be screened and to settle in a reasonable time period. If the particles are colloidal dimensions, they will never settle down because the colloidal particles carry same charge and repel each other. Coagulant are some chemicals which combine with those particles, neutralize and charges neutralize the charges and come together into bigger size and settle down. That is the basic part. Then what happens? After this coagulation, flocculation, they will precipitate down. So next we have to do the sedimentation process. We take a sedimentation tank. There we keep it for long time. If we keep it for like 2 hours, and if we keep it for longer, like 4 hours, so the efficiency of settlement will be higher. Say you have taken a glass of water. Say you are taking a sample of water from a river in a glass beaker and keep it for 2 hours. So what you will see, what you will observe after 2 hours? You will see that after 2 hours, there is a sedimentation. That means a solid particles layer under the beaker. So here in the sedimentation part, the water is allowed to flow through a sedimentation basin or clarifier. Sedimentation basin is a concrete tank and is circular or rectangular in shape. It can hold water for a longer time without damage. Longer time gives better efficiency. So then if we keep for longer time, then all the sediments will be settled down and we can collect the pure water from the upstream. Then is the filtration. Next part is the filtration. So filtration unit is basically the sand filter. So we keep the different size of the different layers of the gravels, consist of multiple layers of graded gravels. The gravels at the uppermost layer are bigger in size and those at the lowest layer are finer size. The pore openings between the sand grains are smaller in size compared to the flow of particles, so that they cannot pass out, allowing water to be filtered. So you understand that if the spacing between the sand, gravels, is smaller than the particles which carried by the water, they will be removed from the water and we can purify the water. So upper side we take the larger gravels and at the lower side we take the smaller gravels. Disinfection is very important part. How we disinfect? So generally you know that we use the bleaching powder, that is chlorine. So how it works? So this is very important reactions. So here you can see that first chlorine react with water, we get HOCl plus H plus Cl minus. Then from the HOCl we get HCl plus nascent oxygen. So this nascent oxygen is highly reactive and it attacks the enzymatic part of the pathogenic cells. Then they are destroyed. Pathogenic cells means the microorganisms which causes disease, that is called pathogens. So this pathogenic cell, how they will be destroyed? So how chlorine works? So first chlorine react with H2O and ultimately we get the nascent oxygen that is highly reactive and it attacks chlorine, it attacks the enzymatic part of the microorganism, that means the pathogens, and destroy them. So it destroys the enzymatic process in the pathogenic cell and thus kills them. So that is the basic principle how the chlorine works. So chlorine is highly effective and it works for the whole days, long time, long hours. But it has also problem, it has also disadvantage, like chlorine can create the chloroform, CHCl3, that is carcinogenic, or trichloromethane, that is toxic. So in the European country, they use the ozone for the purification process, but it is very costly. So in India, we can't use it. So hardness softening process. So if the water contains hardness like calcium, magnesium, salt, we can do the softening process. There are different types of softening process, like temporary hardness can be removed by simple boiling, but for permanent hardness, we have to do different procedures like soda lime process, ion exchange process, permutate or zeolite process. So this process we can do. Now, that is the schematic diagram. So I have described first, then I am showing you the picture. So this one is the surface water. If it is told that describe the surface water treatment along with the schematic diagram, then you have to draw this picture, like surface water from supply, then for screening, then the rapid mixing. After that, in the flocculation basin, you can see this, the flocculation basin, we can do the coagulation flocculation process. So first part is screening that you have learned, then is rapid mixing, we add the coagulant, then in the flocculation basin, after that it is a sedimentation, and at the last of the sedimentation tank, we get the solid plus water, what is precipitated down, that is basically called is sludge. After that, we use the rapid sand filter, then very important part, that is the disinfection, then we can store our pure water and we can distribute. That is the total procedure of surface water treatment you can describe. So here you can see elaborately that the surface water treatment, we are doing the steps, that is coagulation, flocculation, sedimentation, sand filter, fine filtration. Then we are getting the water. And this brackish water can go to RO, then ion exchange. Okay, there are all the procedures. So this is the primary treatment you have understood. In the primary treatment, basically we remove the large particles or the dust materials, few the suspended solid particles, these parts. But the organic matters are not removed. So for this reason, we require the secondary treatment. So secondary treatment is a treatment process for wastewater to achieve a certain degree of effluent quality by using a sewage treatment plant with physical phase separation to remove settleable solids, and a biological process to remove dissolved and suspended organic compounds. Okay, so there are different procedures. So one of these is the trickling filter. So main part we have to keep in mind that is like in the secondary treatment, to remove the organic waste, we require microorganism and we require oxygen to make the aerobic decomposition. Aerobic means in presence of oxygen. Anaerobic decomposition is also possible, but it creates the different gases like ammonia, H2S, and which creates very bad smell. So in the trickling filter, you can get the figure here. It is a type of wastewater treatment system. It consists of a fixed bed of rocks, coke, gravel, slag, polyurethane foam, etc. Or also we can use the plastic media or ceramic media. Basically, here we take this material in this place, and it is covered by a gelatinous substance which contains microorganism. Microorganism means different types of bacteria, protozoa, virus, etc. All these things. And here you can see the sprinklers. So that means from here the waste water is coming. Okay, you can see here the sprinkler, all these things. And through this, the wastewater is moving through this particle. And this particles contains what I told, the microorganism. So when the wastewater will pass through these materials, then the organic matter will be decomposed. And ultimately, from this outlet, we will get the pure water. So that is the basic principle. So mainly we require the microorganisms and oxygen. And this setup is huge. It requires the huge area, and it requires the cost also for the establishment, but its efficiency is very high. And another method also we can use, that is called rotating biological contractor. And the rotating biological contractor, here there is a rotating disc. So you can see the wastewater is here in a tank, and the rotating disc that contains the microorganism. So what is the advantage here? When this disc will be dipped into the wastewater, so the decomposition will take place, but when it will move upward direction. So when it will move, so this portion, first when this portion is under, this is the immersed in the wastewater, so the decomposition will take place. And in the upper section, this section, upper section will get the oxygen. And it is rotating, so again the upper section, this upper section will come down, and the lower section will come up. So in this way, the lower section again will get the oxygen, and the upper section will be immersed in the water bodies which already has got sufficient amount of oxygen, and the decomposition will take place. So that is a very good process, because there is no deficiency of the oxygen. So this benefit we get for the RBC. And here you can see it is for industry, and industry we use this one. So in the wastewater flow, the rotating disc is moving such a way. Next is oxidation pond. So oxidation ponds, also called the lagoons or stabilization pond, are large shallow ponds designed to treat wastewater through the interaction of sunlight, bacteria, and algae. Algae grow using energy from the sun and carbon dioxide and inorganic compounds released by bacteria in water. So here you can see that means this pond is made such a way that the anaerobic, that is the decomposition, will take place automatically. That means there is the sunlight, the water is here, so air will move, and the upward, that means upper layer, there will be aerobic decomposition because it will get sufficient amount of oxygen. But at the lower side, there may be the anaerobic decomposition because the amount of oxygen is less. So this is a problem for this oxidation pond. because it may create very bad smell because of creation of different gases, like I told you, like from the anaerobic decomposition we get ammonia, H2S, etc. So we get the clean water from the other side. So this process also we can use to decompose or removal of BOD, that means organic waste materials. Next, another important part, that is the treatment of sewage. So we get the sewage, the sewage sludge treatment. Sludge we get from primary treatment and secondary treatment also. So here you can see that we are getting from primary decantation, that is the primary sludge. From the secondary decantation, we get the secondary sludge. So sludge means basically the solid plus water. If like in the sedimentation tank, I have shown you that if we keep the dirty water, which let's say which contains solid materials. So if we keep for 2 hours or 4 hours, so there will be precipitation. So this is called sedimentation. So that is called sludge. So sludge contains water plus solid materials. So this sludge, we are taking the pure water from the upper side, but the lower side contains, the lower part contains the sludge. So how we dispose this sludge? We cannot dispose here and there. If we bury under the soil, then it will create the soil pollution because it may contain different types of toxic materials. And if we dump into the sea or river water, so it will again create the water pollution. So we have to do the sludge disposal such a way, that means it should not create again any other pollution. So it must be eco-friendly. So from this sludge, we can create the biogas. Another thing, that means this sludge, first of all, we have to dry it out to remove the water which it contains. After that, it can be used for construction purpose, like say building construction, road construction. Then there will be no harmful effect of this. So here it is the design of the sludge treatment. Sludge treatment design is given here. So the sludge treatment is also a great part. That means we cannot dispose the sludge here and there. So if the sludge is very high, huge amount, so we have to take care of this also. The last part is the tertiary treatment. So in tertiary treatment is the final cleaning process that improves wastewater quality before it is reused, recycled, or discharged to the environment. The treatment removes remaining inorganic compounds and substances such as nitrogen and phosphorus. So it may contains nitrogen, phosphorus, this nutrient. So that must be removed if we use for the drinking purpose. So how it can be removed? So here you can see we have used, that is the aluminum sulfate. Then it reacts with the phosphate. This aluminum sulfate react with the phosphate and it is precipitated down as aluminum phosphate. So it will not be in the water. So in this way, as the precipitate of aluminum phosphate, the phosphate part will be removed. And if the nitrogen is present in the water bodies, how it can be removed? So generally it present in the form of ammonium ion. So ammonium ion plus oxygen. By the presence of aerobic bacteria, we get nitrate. Then this nitrate plus organic matter plus anaerobic bacteria, it converted into nitrogen. And this nitrogen will come into the atmosphere and there is no harm with that. Then, so it is in this way we can remove the phosphorus and nitrogen, this nutrient present in the water bodies, that can be removed. Still, after that, after all this treatment, also the water may contain some fine particles or suspended solid particles. So for this reason, the water can be passed through activated charcoal. It can be passed through activated charcoal, which removes suspended solids, some bacteria, and small quantities of organic materials still present in water. And after this treatment, water will be suitable for drinking. So if we want to use the water for drinking purpose, we have to do the tertiary treatment. Okay, so you have learned what you have learned today. If I like to summarize, so you have learned number 1, the primary treatment and schematic diagram. Next is the secondary treatment. In the secondary treatment, there are different procedures like rotating biological disc or trickling filter. And also you have learned the tertiary treatment. Also, you have learned very important part, that is the disinfection of the water. So how we are doing the disinfection by using chlorine, bleaching powder. Sometimes you get the smell of the chlorine when you use the treated water. So this is the reason, because we use the chlorine for the disinfection purpose. So now I hope that you can answer this question. That is, write down the purpose of primary, secondary, and tertiary treatment. So in the, you have to describe that primary treatment, what type of material can be removed, like grit, large particles, suspended particles, etc. And the secondary treatment, you can remove the organic matter, organic waste materials which is present in the water bodies, that can be removed by secondary treatment. And in the tertiary treatment, what you can remove? The nutrient like phosphorus, nitrogen, this can be removed. So you can write the purpose of the primary, secondary, and tertiary treatment. Next, if it is asked that write down the disinfection process, then you have to write down the disinfection process using chlorine. And also you give the reaction, what I have shown you, that how it will create the nascent oxygen and how this nascent oxygen will destroy the enzymatic process of the pathogens and how they are killed. So this part you have to explain properly. Next question is, describe surface water treatment with schematic diagram. So you have learned very well the schematic diagram. I have shown you. First you have to write the screening process, then the coagulation, flocculation, then sedimentation. After that, you have to use the filtration, that is the sand filter, then the disinfection. After that, we can get the pure water which can be used. So generally the municipality, they collect the surface water from river or other places, and they do this type of, if you go any industry, you can see that they do this simple treatment process, and it can be used for, that means it can be supplied. Basically, the surface water does not contain like arsenic or other heavy metals. That is the problem related with the groundwater. So this type of treatment is not required for the surface water. So by the simple treatment process, after simple purification process, we can use the surface water. That is why this is very important. The rainwater harvesting is very important, we can create our own surface in the roof or any places, and we can store the water, and by simple treatment process we can use this water for our daily purpose. So thank you, students. I hope you have understood the wastewater treatment, and you go through the, first you join with the code and go through the entire study material, and you submit your assignment, then I can do the grading. And if you have any question, any doubt, you are free to communicate with me. Thank you. So I'm ending the session.